Hi, it's Mr. N here, and we've already talked about how to evaluate limits graphically in my previous video. So now we're going to talk about how to evaluate limits without actually having to draw the picture. Okay, now when we write the notation for evaluating a limit, we usually write the letters LIM, which is an abbreviation for the word limit. You take your variable, which is usually x, and you write it as a subscript. Now, some people write it directly underneath the word limit. I like to write it to the side. So it's a subscript, a small x, as an arrow. Now, it doesn't have to be X. It could be any letter. It's just typically X. Functions typically use X, but you could use any letter that applies, and that's actually also fine. Goes to, and the arrow means goes to, some number. And it could be any number, so we'll call it A for any number. And then, usually in its place, you put in some kind of function. Now, if you don't know what the function is, you can just call it f of x. But if you know what the function is, you could actually plug in the function. So this is the typical notation that you're going to see to evaluate a limit. I didn't get to do the f of x part on the graphing because it's kind of just too confusing to type since I couldn't do that as a subscript. But this is more typically how you write evaluating a limit. And evaluating a limit means you find its value. That's what we were doing graphically in the last video. We were evaluating limits. Sometimes we're also just doing the value and sometimes the limits. So I have one sample problem. We're gonna have a number. We have about 7 sample problems altogether because there's going to be for us 2 main strategies. Now there's actually a lot of different strategies and there can be a lot of different kinds of limit problems, but because we're in pre-calculus, we're just going to kind of give you a preview sampler. So we're just going to go over 2 methods. If you really study limits, calculus might do a little bit more. You might learn other methods. But we're just going to start with these 2, right? And so we're going to look at this problem here, evaluate the limit as x approaches -2 of this function. Now, sometimes they put this in parentheses and sometimes they don't. It depends. I decided to put it in parentheses just to clarify, especially when you're handwriting it, it's a little bit easier. But a lot of times, remember this part, that x goes to -2, is usually a subscript and that's in larger font. So you can usually tell the difference between these 2. But so the parentheses are optional. Now, actually, you can almost do that graphically in your brain. Right, so just in your mind, you don't actually have to write this out. You could actually sketch that graph because just look at this and just graph that as a function. Just graph the equation y equals 2x plus 3. All right, so just graph y equals 2x plus 3. That'd actually be pretty easy to graph. Go to 3 up here. Right, there's your y slope. Slope is 2, so rise 2 over 1. Yeah, it's something like that. And what happens when you get to -2? Actually, I didn't graph that very accurate, but I think -2 is going to be about here. So that's what's happening graphically. Now, actually, we could find out, we could draw the graph and figure it out, but we could also just what? Just plug in -2. To solve that, I'm just going to take 2 times and plug in this number, -2 plus 3, and see what I get. And of course, that's -4 plus 3, which is -1. And sure enough, that would be the point, -2, -1. And so -1 is my answer. All right, that is evaluating the limit. Because if you recall from my graphical limits examples, 95% of the time, if the graph you're doing is continuous, which all straight lines are, the limit is the same thing as just plugging in the point. So if you plug in a point, you just plug in the limit and that's it. So it's actually pretty straightforward, all right? The only time it's different is when your graph has a hole or it's piecewise. So we'll worry about it when we get to that. Otherwise, we just plug it in, right? So keeping that in mind, let's look at this example. Find the limit of, as x approaches 5, of the graph, negative square root of x plus 1. This time I didn't put it in parentheses. The negative is with the graph, not with the 5. All right. Now you actually could think, is this a continuous graph? And actually square root graphs are actually not 100% continuous because remember, they start nowhere. But let's just plug 5 into this and see if it works. And now if it doesn't work, that means I try to plug it into a part of the graph that doesn't work. But if it does work, let's just see. Let's plug 5 in for x. So it's negative square root of 2 times 5 plus 1. I'm just taking this number and I'm just plugging it in. I don't even need to worry about this part. It's just kind of decoration, right? Just take 5 and plug it in, right? So it's negative square root of 10. 2 times 5 is 10 plus 1, 11. And without a calculator, that's as simple as it gets. So that's my answer, because that is an answer. I just plug it in, and as long as you don't get an undefined situation, then you're fine. Now we'll talk about what happens when you do get an undefined situation, but if you just plug it in and you get a number, even if it's a square root, a fraction, a whole number, negative, positive, as long as you get an answer, it doesn't really matter, okay? It just can't be imaginary or undefined. Right? So keep in mind, let's look at this problem here. Let's find the limit. And if you graphed this, this would be the 0.5, negative square root of 11 would be a point on the graph of this. But you don't, here's the thing. We're going to try to solve all these without actually needing to graph them. All right, we're trying to find a shortcut because graphing it can get very, very tedious. And I don't think you'd want to graph this if you didn't have to. All right, that's kind of, we kind of have done this before, and they're not fun to graph. I don't really like graphing them. We could do it, and we could use Desmos and graph this, but I guess I'll bet that I'm just going to plug negative 3 into this and see what happens. So I'm going to plug in, that's a negative 3 into all these things. That's negative 3 minus 3 from here. That's negative 3 minus 3. Negative 3 squared plus 2 times negative 3 plus 2. I'm just going to plug it all in. Right, and let's work it out. That's negative 6 over 9 minus 6 plus 2. Right, that's negative 6 over that's 3 plus 2, which is 5, and that's it. You don't even have to make it a mixed fraction, just negative 6/5. If you plug it in, take this number, plug it in, and if you don't run into any issues, as long as I didn't get a does not exist, so I'm fine. That's it, I'm done. So basically, to evaluate a limit when you don't have a graph, for the most part, now when you get to calculus and things get a little bit harder, there are other things that can happen, but for this class, just take the number that you're finding a limit for, plug it in, and work it out. That's pretty much it, okay? That works even for something like, not those, that's something else. This situation right here, all right? So this is a trig function. Some students get very intimidated by this, all right? But the cosine graph is a continuous one. Let's just plug in pi over 6 for cosine, all right? So find the limit as x approaches pi over 6 of cosine x. Now cosine x is my function. I didn't put it in parentheses, but I can if I want. Right? I just did it just now to clarify. Just plug pi over 6 into that, all right? So find the cosine of pi over 6. And my goodness, we only calculus the whole year. I kind of think we know that right away, all right? Quadrant 1, and it's just going to be square root of 3 over 2. We're done. That's it. All right, we're actually just plug it in, finished. So this should actually be pretty quick. Now this is a bonus problem. As I said, the limits don't always have to be x's. This is find the limit as h approaches 3 of the function 2x plus h. Now something like, how do I graph 2x plus h? Here's the great thing. You don't even have to know how to plug it in. Now I know this has 2 letters. This is a bonus problem, right? But I'm just showing you. Plug in 3 for h and see what we get. And I get 2x plus 3, and that doesn't simplify. So that's my answer. All right, so even if there's 2 letters or letters you don't know, take the letter they ask, plug in that value, and as long as you don't get a does not exist situation, you're done. All right, that is your answer. Usually, if there's only 1 letter, like in all the other ones we did, you'll get a final answer. If there's 2 letters, you plug in the 1 number you get, and you just leave the other x there, or whatever letter it is. I also could have plugged in x as approaches 3, and I would have plugged in the 3 here. Right, if I'd found the limit as x approaches 3 of 2x plus h, right, then I would have plugged in 3 for x, and I would have gotten 6 plus h as my final answer. So it's actually pretty straightforward, okay? So you're probably thinking this has all been pretty easy so far. I just plug it in, right? So let's go on to the next part, right? So evaluating limits, main strategy is just plug it in, right? Just plug in what you've got. But let's try that with this problem, okay? So with this problem, let's try find the limit as x approaches 2 of this. And if you do that, you get 2 squared minus 4 over 2 minus 2. And the top part is 4 minus 4, and the top part is 2 minus 2, and we get 0 over 0. And even if there's only been 0 on the bottom, this is the 0 that's the problem. The 0 on the top is actually not a problem, because 0 is on the top only. The answer is just 0. But the 0 on the bottom, that's an issue. That means that this is undefined, right? Now, you're probably thinking when we did this graphically, well, hey, that's great. Sometimes limits are undefined, so maybe that's what happened here. But there is another strategy. So if I plug it in and I get an undefined, I need to go to our second strategy. And the second strategy is try to factor first. Factor, if possible, and then cancel, factor and cancel, right, if you can do it. And if that works, then plug in. All right, so now let's actually start all over with this one, because I tried plugging it in and I got undefined, right? But now let's try it again, and let's take this part and factor it. X squared minus 4 is a difference of two squares, remember that? So that factors to x minus 2 and x plus 2, that's this part, all over x minus 2. And if you remember from irrational things, these cancel. So you just get x plus 2, right? And now that you have that, take this x and plug whatever number they have into it. So that's 2 plus 2, which is 4, and that's my actual answer. 4 is the limit, because I'll be able to factor and cancel, and then I plugged in. This is an example of one of those graphs, kind of, where you have a line with a hole in the middle, right? And this is perhaps 2 on the x-axis, but it's the point 2, 4. And there's a hole, but it's still, the undefined part is telling you it's a hole. The undefined means, hey, you got a graph with a hole, but as we saw, graphs with holes, while the value is not defined, it's undefined, the limit can still exist, right? And the limit is 4. So that's kind of what it's like, those graphical examples. So factor first. So these are now, for us right now, these are the only two strategies we're going to use. Now, some of you might be thinking, well, what if I factor and cancel and it still doesn't work? We're going to leave that for another class. Like, we're just not going to enter that. That can happen, but we're not going to do that situation in this class. Where everything in this class will fall into this category, or a third option that we'll do in the next video, right, which is a special case. It doesn't even fall into these, really. Right, we're going to do a special case in the third video, but that's for later. All right, so we're going to just do 2 more examples using this. All right, so let's now, all the directions are evaluate. So let's evaluate the limit as x goes to -3 of x plus 3 all over x squared plus 5x plus 6. All right. Now, we would try to plug this in. And if we plug it in, we get 0 on the top, which is fine. And we can get 0 on the top. What I can't do is I can't get 0 on the bottom. And if I plug -3 in the bottom, I get 9 minus 15 plus 6. And that will turn out to be a 0 on the bottom. So if I try to plug this in, I'm going to get a 0 on the bottom. So that means option 1 doesn't work in this case. But it does look like the bottom part can factor. The top part doesn't factor. This is a separate problem. Right, but the bottom part does. The bottom part factors into x plus 3 and x plus 2, right? 3 times 2 is 6, and 3 plus 2 is 5. And then the x plus 3's cancel. So I get 1 over x plus 2. And now I can plug -3 into that. Right? And I get 1 over -3 plus 2, which is 1 over -1, which is -1. That's my final answer. And again, it's just like this situation. All of these are like this situation most of the time, where it's a line with a hole in the middle, and we're trying to find the limit where the hole is, right? Because, yeah, if we just plug it in, that means we're finding some other spot on a line. But if we get a 0 on the bottom, that means we've got a hole in the graph. But if you just factor and cancel, it's kind of like getting rid of the hole, and you can still find the y value of it. It's the location of the hole. Okay, but that's the short of the story. To find the limit of this, I try to plug it in, but if I get a 0 on the bottom, then I factor and cancel until I get. Now, if you just get a 0 on the top, remember, limits can equal 0. There is no problem with a limit equaling 0. And on the homework you're going to get, I think there's at least one, maybe 2 limits that do equal 0, and that's fine. A limit can equal 0. Right? It just can't have, so that means a 0 is on the top, and that's fine. We just can't have a 0 on the bottom. Okay, and we'll just do one more example. I'll flip this over so I have a little more room. And this is going to be one of the harder problems. Evaluate the limit as x approaches 0 of 1/5 plus 1 over x minus 5 all over x. All right, now that's a pretty unpleasant looking function there. All of this could be graphed. Right? And that's okay to get the limit approaching 0. That's totally fine. 0 is just a number like everything else. The only thing 0 is special is you just can't have a 0 on the bottom. And just if you plug in this number, the top is fine, but if you plug in 0 for x, you get a 0 on the bottom. So this is an issue. So I just did say try to factor and cancel. Well, this one actually has nothing to factor. So actually there is kind of a third strategy. And the third strategy, if you can't factor it, try to simplify it. This is a complex fraction, so I'm just going to look just at this. I'm going to kind of ignore that part for a moment and ignore this. Let's just try to simplify that fraction, all right? Now to simplify, I need a common denominator on the top. So I'm going to multiply this times, it's x minus 5. I'll get 1 times x minus 5, which is x minus 5 over 5 times x minus 5, plus, and over here, I'm multiplying top and bottom by 5. So that's going to be 5 on the same denominator, all over x. Right? This x is just staying, but I'm working at the top. Right? Add these together. I should put the equal sign in the middle. Right? And 5x plus 5, I'm sorry, let me say that again. X minus 5 plus 5, well, minus 5 plus 5 cancel, I just get x over 5 times x minus 5 all over x. That's what I get so far. I'm just adding the top. All I'm doing is I'm working out the top part. Right? And once I have a common denominator, just add this on top. And x minus 5 plus 5, the 5 just cancel, and I just get x. Now, moving on, so I have more space. This is x over 1. So get rid of x over 1, I multiply both sides by 1 over x. Right? And so that goes away because I'm kind of doing on top and bottom, and that cancels. And then here, the x's also cancel. So I just have 1 over 5 times x minus 5. Right? Now, let's see what happens. So I've simplified all I can. Now let's see what happens when I plug 0 in. Now, when I do, I get 1 over 5 times 0 minus 5. Well, that's 1 over 5 times negative 5, right? Because 0 minus 5 is negative 5. And that's negative 1 over 25. And that's my final answer, right? So if the factor and cancel is not applicable, but you have a complex fraction, simplify it. This complex fraction, if you graphed it, would pretty much just be a line with a hole in it. And this spot is where the hole is. So it does still have a value, but you just have to plug it in. You just have to get rid of the parts that cancel first. Okay, so those are examples of evaluating limits. So your strategies first are first just try to plug in. And as long as you don't get a 0 on the bottom, then that's it. Plug in, simplify, you're done. If plug in doesn't work, try to factor and cancel, and then plug in. Right? And if you can't factor and cancel, then try to simplify. Right? And if you've tried all 3 of those, and you're still, and these 2 are the ones you do if you get a 0 in the denominator. Okay, if you get a 0 in the denominator, then you go to those 2. And if these 2 still don't work, actually they should on your homework, they should work. But in this case, if they don't, you'd at this point just say that the limit doesn't exist. Right? Or you would just learn more strategies in a calculus class or another math class that would give you more strategies to deal with it. Because there actually are a lot more strategies out there because there's a lot of different kind of graphs. You can find limits, and we haven't learned all of them. So there are lots of other possibilities out there, but these are the three that will work for us when we need to evaluate a limit. So if you need a kind of a shortcut note sheet, those 3 steps are it. Okay, so I hope that helps you. You should find those hopefully not like too difficult. They're pretty much straightforward because most times you just plug in, factor, cancel, or simplify. Okay, so good luck.